let's discuss this question where it says construct a 3 by 4 matrix whose elements are given by this and this. There are two parts of this question and we are supposed to construct a 3 by 4 matrix. Now what does a 3 by 4 matrix look like? Let's take a look at that first. A 3 by 4 matrix would have 3 rows and 4 columns, and yes, it would look like this. A 3 by 4 can be written as AIJ 3 by 4, which will look like this. 3 rows and 4 columns. The first element present in the first row and first column would be A11. Then you have first row, second column. Then you have first row, third column. Then you have first row and fourth column. There are total 4 columns, right? That's what you get. Okay. What happens to the next one? This is the second row, first column. This is second row, second column. This is A22. The second row, third column would be A23, this element. This element would be A24. The second row, fourth column. What about this one? This is third row, first column. Third row, second column. Third row, third column. Third row, fourth column. And yes, these are 3 rows and 4 columns. As you can observe, this is a 3 by 4 matrix whose elements are these. What happens in case of the first part? Let's try to find each of these elements for finding the matrix as in the first part. Let's try to do that, yes. So for first part, what do I know? I know that Aij is equal to half times modulus of minus 3i plus j. This is what it is equal to, right? And since I'm supposed to find all of these, let's try to make a grid over here first of all. Let's construct a grid. Okay, just a minute. Let me take lesser space. Yes, this is the grid. And grid, yes, let's make a partition over here. Let's make another partition over here and a partition over here as well. So A11 will be solved over here. A12 would be solved over here, right? Calculation errors can be avoided, like all of this makes your calculation look easier, look simpler, right? A13, A14, right? What happens in this case? This is A21, A22, A23, A24. We'll solve each of these here. A31, A32, A33, A34. This is what we'll do, right? So let's try to solve each one. This is a grid. The first one says A11. A11 would be equal to half. This is minus 3 plus 1. The modulus of minus 3 plus 1. Minus 3 plus 1 is actually equal to minus 2. The modulus is equal to 2. So this is 2 upon 2, which is equal to 1. That's the value. This is equal to 1, right? Next, A12. A12 would be equal to 1 by 2 modulus. This is minus 3 plus 2 modulus. Minus 3 times 1 plus 2. This is what you get. What is this equal to? This is minus 1. The modulus is 1 upon 2. So this is equal to 1 over 2. This is equal to 1 over 2 over here. What happens in case of A13? This is equal to half modulus minus 3 plus 3. And you may observe modulus minus 3 plus 3 is equal to 0, simply 0. What about this? This is half modulus of minus 3 times I, that is 1, plus 4 modulus. What is this equal to? Minus 3 plus 4 is equal to 1, 1 upon 2. This is equal to 1 over 2, as you may observe. So these are the values of elements present in the first row. What about the second row? Let's solve for the second row. What do we have over here is, this is half minus 3i. This is minus 3 times 2, which is minus 6 plus 1 modulus. Minus 6 plus 1 is minus 5. The modulus is 5. This is 5 by 2. What happens in case of A22? A22 is half minus 6 plus 2 modulus. This is minus 3 times 2 plus 2. Minus 3 times 2 is minus 6 plus 2. This is minus 4, the modulus is 4. this becomes 4 by 2, which is equal to 2, simply 2, right? Next one, A23. A23 is half minus 6 plus 3, which is again 3 by 2, as you can observe. In the bracket, in the modulus, you have minus 6 plus 3, which is minus 3. The value of modulus would be 3. A24 is half minus 6 plus 4, which is 1 by 2 times 2, which is simply 1. Minus 6 plus 4 is minus 2. The value of modulus is 2. 2 over 2 is simply 1. This is what you get. A31. A31 is 1 by 2 modulus minus 9 plus 1. What is this? This is actually minus 8. Modulus of minus 8 is 8 by 2, which is simply 4. This is simply 4. What happens in case of A32? This is 1 by 2 minus 9 plus 2 modulus. This is equal to what? Minus 7 modulus, which is 7 by 2, right? Although you may have observed some kind of pattern, so you can think of that pattern as well. This is 2 by 2, this is 1 by 2, 0, and actually modulus being there, this is 1 by 2, or it could have been minus 1 by 2 as well. Here what you observe is this is 5 by 2, 4 by 2, 3 by 2 and 2 by 2. Similarly, this is 8 by 2, 7 by 2, you will get 6 by 2 and 5 by 2 over here. Let's try to find that, right? 1 by 2, this basis becomes minus 9 plus 3, which is simply 6 by 2, which is 3. How did you get that, right? This is A33, minus 3 times 3 plus 3, minus 9 plus 3. A34 would be half times minus 3i would be minus 9 plus j, which is 4. Minus 9 plus 4, the modulus is 5. This is 5 by 2. And since we know these values, therefore the matrix A, therefore A 3 by 4 matrix would be equal to what? This will be equal to 1, 1 by 2, 0, 1 by 2. The first row would be equal to, or write the first column first. This is 1, 5 by 2 and 4. These are the elements that present in the first column. The second column is 1 by 2, 2 and 7 by 2. 1 by 2, 2 and 7 by 2. The third column is 0, 3 by 2, 3. Those are the elements present in the third column. The third column, after the third column, we have the fourth column, that is 1 by 2, 1 and 5 by 2. That is the matrix of order 3 by 4. This is the 3 by 4 matrix for part 1, as you can observe over here, right? I'll get aside for a minute for you to take a look clearly. And yes, next we'll discuss part 2 after this. What does part 2 say? Let's talk about part 2 after this. Okay. So in part 2, we'll talk about a different Aij. Aij is equal to 2i minus j. This is equal to 2i minus j. And you're already used to solving for A11, A12, A13, A14. This is very easy for you. What I'll do is I'll directly construct the matrix this time around. A11 will be equal to 2 times 1 minus 1. A21, this would be equal to 2 times I, which is 2 minus 1. A31 would be actually equal to 2 times 3 minus 1. I can write it as this, yes? That is easy. A12 would be equal to 2 times 1 minus 2. A22 would be 2 times 2 minus 2. A32 would be 2 times 3 minus 2. What happens in case of A13? 2 times 1 minus 3. This is 2 times 2 minus 3, 2 times 3 minus 3, right? A33. A14 would be 2 times 1 minus 4. A24 would be 2 times 2 minus 4, and this would be 2 times 3 minus 4. This is the matrix that we are forming. What are the values of each of the elements? Let's write that. This is, which implies A equals 2 times 1 is 2 minus 1 is 1. 2 times 2 is 4 minus 1 is 3. 2 times 3 is 6 minus 1 is 5. These are the values that you will be getting, right? This is 2 times 1, which is 2 minus 2 becomes 0. Right or not? Yes. This is 2 times 2, 4 minus 2 becomes 2. 2 times 3, 6 minus 2 becomes 4. This is what you get, right? What next? 2 times 1. This is 2 minus 3, which is minus 1. This is 4 minus 3, which is 1. 2 times 3, 6 minus 3, which is 3. This is what I am getting. What next? 2 times 1 is 2 minus 4 is minus 2. This is 4 minus 4, 0. This is 6 minus 4, which is 2. And yes, this is the required matrix. Let me get aside for a bit. And yes, this is my answer for this question over here. Alright. Is that all in this question? Yes, this is all in this question over here.